Hey guys, I hope you're well. Today we are extending our last lesson where we were looking at finding the sides of a right angled triangle using trigonometry. We're still doing that, of course, but we're just going to look at slightly more complex questions. But to start off with, let's just look at this very quick example, okay, where we're going to revisit last lesson just to ensure we know what we were doing. So first of all, can you remember my 4 steps? The first step, of course, was to label the 2 sides given to us in terms of the angle given. So in this case, we have the adjacent side, we have the hypotenuse side. That's the first step, of course. The second step was to look at that rule SOHCAHTOA and to identify which of the 3 ratios or rules that we were using. Now in this instance, of course, we're using adjacent and we're using hypotenuse, which would be that middle rule of cos. Now, whether you write the rule down, that's up to you. Cos theta equals adjacent over hypotenuse. But the third thing that we were doing was, once we knew what rule we were using, we were then going to apply the rule to the question. So that means I grab the values of 60 degrees, for example, and I'm going to place that where the theta is, so cos 60 degrees. I'm going to grab the amount of x meters, which is the adjacent. I'm going to put that where the adjacent side was, and then the hypotenuse, I'm going to replace it with the 10 there. Okay, I'm going to put the 10. So that was our third step. So again, first step, to label those 3 sides, or the 2 sides, sorry, and in regards to theta. The second step was to choose your rule. Third step, to apply the rule. And of course, the last step, the 4th step, was to answer or solve that equation. Now in this instance, we're going to multiply the 10 across, because the opposite of divide by 10 is times by 10. We're going to do something like 10 cos 60 degrees. Okay, we're now going to get our calculator out, of course. We're going to type in 10 times cos 60. Now, in terms of this answer, you're going to find that it's going to be quite a nice little answer, I believe. So 10 times cos 60. And we're going to get an answer of 5. So this is actually 5 meters. Okay, and so again, the steps that we were looking at, of course, number 1 was to label the sides, 2, identify the rule, 3, apply the rule, and 4, solve the equation. So nothing different to what we were doing from last lesson. Now, today, we're kind of going one step further. Now, you might think this next question, this example 2, looks exactly the same as what we were doing. You will see a slight twist. First of all, label the sides, exactly like we were doing. We can still see we've got the adjacent and the hypotenuse. Now, because we're still using the same 2 sides, okay, when I look at my SOHCAHTOA, of course, for my second step, we're going to still recognize that we're using that second rule, the cos rule, the cosine rule. So first step, label the sides. Second step, find the rule. Third step, let's now apply it. I'm going to apply it straight away because we just used the cos rule. So cos 50 degrees is equal to my adjacent over my hypotenuse of x. Okay, can you now figure out perhaps why this rule is slightly more challenging? Now, what you might notice, the difference between the 2 of them, of course, is that the letter is on the denominator. Now, this causes a unique problem because we can't just times that across and solve our equation. It doesn't quite work, because if I do that, the opposite of divide by x will be times by x. I get 10 equals x cos 50 degrees. And the whole idea, of course, is to find out what x is on its own, to isolate it so it's on its own. We want this x equals. So now what we have to do, we have to get this cos 50 degrees, and we have to move that across. So what's the opposite of times cos 50? Well, that would be divided by cos 50. Now, what I want you to do is to have a look at that part. I'm just going to get rid of my working out, and I want you to look at the very first thing we wrote down, and I want you to see if you can see anything that's actually happened. Now, what you might notice is that the cos 50 and the x have ultimately actually swapped positions there. Okay. Now, if you remember, if you have the letter on the bottom or the denominator, and you know that you just swap them over, then by all means go for it. Okay. But again, the whole reason that happens is because you're timesing by the x, then you're dividing by that cos 50 degrees. But ultimately, it just swaps. And so now, instead of timesing the two things together, we're dividing. So 10 divided by cos 50. Now, if I use the divided by sign, it's one straight line. Okay, now what I mean by this, because I can't show you the calculator that I'm using, if I calculate like this, 10 divided by cos 50, okay, you're going to get the answer really quickly. And it's going to say something like 15.557 ... So let's say 15.6 meters or centimeters, or whatever it might have been. I think it was meters. Okay, to one decimal place. One thing you'll notice, if you do happen to type it in like a fraction like this, okay, when you press cos, it will always open the brackets. You put the 50 in. You must close that bracket off. Now, you don't have to do it when you're simply doing one line and timesing it like that. But whenever you're using a fraction, it doesn't like you not closing that bracket off. And so if you don't close the bracket off as a fraction, it will come up with a math error. Okay, so you just need to go backwards and put that little back bracket in. So again, if you do it as a fraction like that, you must close your brackets off. Otherwise, they're pretty lenient. It doesn't really matter too much. But either way, we end up getting this 15.6 meters as our final answer. So again, you can see the two differences, and I'm just going to highlight them. Let's go put it in blue, okay, as my first piece of working out. That first one, we had a number on the bottom, so we simply times it across and job done. But this one, whenever you have a letter that's the denominator, we need to swap them, and we end up dividing them together. And that's really significant. Okay, now I've got 3 questions here. If you feel up to it, by all means, pause the video now and have a crack at these 3 questions and then see if you got these answers right. But of course, if you just like to follow on, you're most welcome to do so as well. Now, either case, my 4 steps will always remain. First of all, label your 2 sides, sorry, I keep saying 3, 2 sides, opposite, adjacent, hypotenuse. Identify your rule, apply your rule, solve your equation. Okay, nothing different from last lesson. So in regards to the 40 degrees, we have the opposite side and we have the hypotenuse side. Step 1 done. Step 2, let's look at our SOHCAHTOA. Now, of course, you might not need to write this out every time, but certainly it might help. Now, I'm using O and H. I might highlight those just to recognize that. O and H is our first one, is our sine. Now, again, if you would like to write out sine theta equals opposite over hypotenuse, then you're most welcome to do so. You again might feel that you want to apply the rule straight away. First step, label the sides. Second step, work out your rule. Third step, we now apply it. So sine, instead of theta, it's sine 40 degrees. Instead of opposite, we're going to put 10, and instead of hypotenuse, we're going to put x. Now, this is again where you start to see this is a harder question because x is a denominator. You can't just do that straight times. Now, of course, you can times it across, then we need to divide by that sine 40. But a lot of you will just go, I'm going to swap them over. 10 divided by sine 40. Now, once you've done that, that's kind of the hard step. The rest of it is now just calculated. Again, if you're going to put it as a fraction, and on my calculator, I'm going to do it now as a fraction, we type in our sine at 40, and notice you must close those brackets off. If you don't, it will come up with a math error. I get 15.557 ... which means I'm going to get x equals 15.6, and that's meters. Okay, that was the same question as the last one. Look at that. Very, very similar anyway. I used the 50 degree instead of the 40 degree. Funny that happens. Okay, next one. How'd you go? Again, if you have not paused it, pause it now and see if you can do the next one, using the first example to help you. Okay, how did you go? So, first of all, label your sides. We have the hypotenuse. Notice how I just rotate that triangle around. It's still the hypotenuse, still along the side. We still have the adjacent side because it's next to the 60. Recognize we don't have that opposite side. So if I look at my SOHCAHTOA, yes, I know it's right next to me, okay, but I like to write it out every time so I remember it. Adjacent and hypotenuse. Adjacent hypotenuse is cos. I'm now going to apply the rule straight away. So cos 60 degrees equals my adjacent side over my hypotenuse. Beautiful. Well, this is an easy question, isn't it? Okay, I did my adjacent over my hypotenuse. So now I can simply times the 15 across. So 15 times cos 60, okay, and I can get my answer. Okay, and I reckon this will be 7.5 just by looking at it. 15 times the cosine of 60, and look at that, 7.5. All right, and that's meters, and that's my answer. So that's an easy question, of course, and I did that on purpose just so you can see when you have a hard question versus when you have the easy one. I mean, the harder ones aren't that much different. You just need to remember to swap. Now, let's have a go at the next one. Okay, so label your sides. We have opposite and we have the adjacent. So again, if I do my saw kata, can you see which rule we're using here for the opposite and adjacent? Well, of course, you would say opposite and adjacent is toa, tan. I'm going to rewrite my rule. Tan theta, or tan 70 degrees, equals my opposite side over my adjacent. Now do you see we have the harder question again? The x is the denominator, so let us swap them around. We're timesing by the x, dividing by the 1070. So x equals 8 divided by 1070. Now I go straight to my calculator. I'm going to use the divided by sign this time. So 8 divided by 1070. Notice I'm not going to bother closing the brackets. It will still work. We end up getting x equals 2.9117 ... So x equals to one decimal place 2.9, and it's centimeters, and I've got my job done. Again, you could do it to 2.91, you could do it to 3, lots of different options there because I didn't ask you. Gents, that's literally it. That's the harder question. It's when you have the denominator is the letter, you literally swap them around. Okay, otherwise simply times it and then divide it, but ultimately it swaps positions. Just make sure, of course, your 4 steps will always remain. First of all, label your 2 sides in regards to opposite, adjacent, hypotenuse. Second of all, choose your rule. Third of all, apply the rule. And fourth, solve your equation. Drop me a line at Canvas on Messenger if you need any assistance. And remember, you can use HotMath too. I might start seeing some work on that as well. Have a wonderful day.